So I would like to present you next speaker. He is Stefan Kraus, and his presentation title is Let the Robots Test. So acceptance test-driven development with robot framework. So Stefan, the stage is yours.
Thanks a lot. I hope you can hear me well. Nice, great. Hi, I'm Stefan. Only a few words about me. I'm a senior software engineer by UL Solutions. This is a company that majorly tests fire extinguisher and other things that could accidentally went into flames. But we also do software testing with our company and software reliability things. I'm writing Python now for, I guess, more than 10 years. It was 3.2, 3.3. And right now, majorly, I'm doing a lot of testing work as a certified tester and test manager to make sure the whole software we write from day to day is as the clients want and is safe to use for everyone. I will have the examples and slides. It's a whole bundle where you can afterwards also try it out online on my GitHub. So if you have any more questions or want to look into it more deeply, feel free. It's not right now, but will be. I'm not alone here. I brought you someone with me, and this is Pascal. Pascal is a project owner, and Pascal loves to find new public data that we and he can play around in the end, where he can tell stories about it and hopefully find interesting things. And Pascal came to me and said, hey, I have this FARS data set about fatal accidents. This data set, if you have not looked into it before, it's pretty nicely as it has a lot of columns where you can try to find different ideas, visualize different things, and it's very flexible and public to use. And he asked me, hey, I have a first idea. Can you just visualize number of accidents per 1,000 people per state? So I'm have a look at it. Good, set, done. So I built a simple chloropleth map where for each 1,100, sorry, based on the accidents and the number of people living there, it gets darker if there are more accidents, and it gets brighter if there's not so much accidents. I thought that would be quite nice. Pascal, unfortunately, was not quite as happy as I was. He says, nah, that's not good. Please, let's visualize each accident on the map. And this data set had 40,000 points, so the data set looked pretty much like this. And, well, he was also not happy about that and said, okay, this looks completely terrible. I can't even see all the single points. How I can't tell any story about that. Please make sure I can filter by daytime and accident of streets. Okay, Pascal, just tell me what to do. So I did this, yeah. I used the panel library the whole time in my in this work. So provides me with a user interface with a single button, with sliders where I can set the date of the accident. This is only the data for the year 2021. And a simple drop-down where I can also provide the street type. And I thought I have completely hit now, and he is happy. Unfortunately, we miscommunicated again, and he wanted to filter not by date time, but by daytime, so on which hour the accident was. And he also wanted to have multiple different streets selected. And so, after a few iterations and a few more problems between each other, we finally got it pretty much working, and that is also what you can play around with in the examples afterwards. But thing is, we were both kind of not happy how it went. Yeah, he says, hey, I'm telling you exactly what I want, and the developers can't really listen to me and can't implement it like it makes sense. And I think, okay, why can't these project owners just say what they want in a way that we are from the start both on the same side and can properly do it right on the first try, because reworking the whole time is obviously a very cost and time intensive. And the good thing is, there in the testing community, there is a good approach that has quite this idea in mind. Yeah, it's called acceptance test driven development, and you've probably done behavior driven development before, and that is pretty much just one level above and a bit broader. So the basic idea is you bring the team members, your stakeholders, your developers, your testers, and whoever has something to say in the project together and define the tests together. What shall be tested? How should it be tested? And this shall be done at first. Yeah, you do not want to start with an implementation and afterwards write tests for it, because then you come into exactly this problem, but you want to have the tests first. And when these tests pass and are properly implemented, then the user story or your ticket are done. We'll see some example. And the main thing is you want to have the perspective from the user, and you want to have it in a clear language. You do not want to start with anything that only a developers understand, but things how your user would want to handle your UI, your website, name it. And the developers, maybe you say this too, just writing out tests and then I need to click more and more and read more how exactly it implemented is just cumbersome and takes time. And therefore, for the rest of the talk, I wanna present the framework I recently or in the last time worked the most with, which is Robot Framework, which makes it possible to have these acceptance tests that one defines in a good and clear structure, and hopefully in a way that the developers have no so much work in the end at all. Some few words about the Robot Framework. It's an open source automation framework. It's based or funded by a non-profit foundation, and it's actively developed since 2005. So 20 years open source development under a nice license, so you can work with it also in a commercial context. We are now at version 7, and they're still actively maintaining, implementing things that the community wants to help. It's keyword driven, behavior driven. We'll see that the tests are in a form how a user or someone would actually interact with the website. So it's about the how and about the what and at the how. Especially in the most libraries, and what I also used it for is user interface and automation. So that's mostly what users interact with. It's some form of UI, and this robot framework helps you to automate tests on these user interface level. Yeah, as described before, the tests, and we'll see a test in the next slide, is human readable, but the robot framework itself will make it executable, and we'll see how it does that. Last but not least, and maybe a good reason to have it seen here, is it's written in Python. It's a nice code base actually, and it's greatly extensible for your own needs if you need to. Okay, let's see how Robot Framework works in general before we come into the details. We have a test suite which contains multiple tests, and right now we see one of these tests here. I have one test that says, okay, in my drop down where I select multiple row types, I want to have that when I only select 2 row types and not all, it should please be less accidents than before. And the test describes, okay, I want to visit a website, I'm gonna show the accident locations with this button, then I search for the accidents, and I hope it's now less before. Yeah, we have single steps on these levels of abstraction that define the test case and how it should be tested. These test suite and these single lines that you have here are keywords. Keywords are self-defined. You can also have own keywords, and for example, one way of having this keyword is, okay, when I want to search for accidents, I also need to do the following steps. And you can do that again and again. Yeah, you can use keywords by using other keywords to go from a higher level of abstraction to the lower level of abstraction until you are finally in the end at such a low level that you can actually just implement the functionality that you want to have. Yeah. And while the left side is more something that stakeholder, product owner, and so on do, because on the library part you need developers to actually write code, while for abstraction, breaking it down, normally developers are way better than your stakeholder. That's the general way how the framework works, and now we look into some concepts of it and how it's structured. We're gonna start with the left side pretty much. Yeah, we have here multiple test cases. Each test case, that's the red side here, has a test case name, which I can also filter later on, which I also have in all logs. And one test case normally consists of multiple keywords that are executed after each other. You can have, if you want to, have multiple test settings, for example, text to filter it or to map it with your requirements or your or your IDs, and which we will also see later in the test suite parts. We have now these sections which consist of all test cases for this specific test suite. You can have multiple test suites, but we'll come to it later. I can then in my terminal just execute the robot command that I previously installed with pip robot framework. I can give him this this test suite file, or I can also say please only execute tests that start with this specific name. So because when I execute all tests the whole time, gets pretty cumbersome. Okay, let's look into one of these tests. What I personally dislike a bit about the test that I had before is this part. Yeah, it says, okay, I look at the map and then I search for accident points on the map, and I also have it here. And what I dislike is that I have state in my keywords. And what Robot Framework here can, which makes it a bit more unreadable, but easier to program and reuse the single keywords, is that you can introduce variables. You do that by simply using this parts of the syntax, an equal sign and two spaces, and then if the keyword will return a result, it will save it in the variable, and you can also use it in other ways on the next step. So you can easily reuse with different combinations the same keyword without any big hassle. Makes it for me way easier, and I think also the keywords get way more reusable. Okay, that were the tests themselves. The tests are part of a test suite, which does consist of single test cases, which are independently of each other and also executable independently of each other, hopefully. We have keywords to self-define keywords. We'll come back to it in the next slide. Yeah, I do not need Python at this point when I do not want to have it. I can have variables to override for specific environments. For example, in my dev tooling, I maybe want to have localhost. For my production or my staging tooling, I want to have a different variables. I can simply declare different variables in my test suite, and I can override it later by different calls and different environment setups. Last but not least here, the settings, where we also come in, is a place for general test suite documentation, imports, usage declarations, annotations, tags that you want to have in all tests. So basically the everything that I need to have, or not only for a specific test class, can be in there. Okay, let's look a bit more after we've now seen the test cases. Let's look into the keywords. Yeah, each single line of it is a keyword that needs to be specified and implemented in any way. Yeah, and keywords are also a great way to refactor code or to express one common concept into into a single keyword to reduce duplication. For example, here we have 3 times the same behavior. Yeah, we look at the map, or the user looks at the map, then we search for accident points on this map. And below I have it again and again. And I can simply replace this with a keyword that I implement inside of these keyword sections, where I now give the keyword a new name, search accidents on map. I refactor, or I put these 2 low-level keywords inside, and then I can also return inside a keyword. Yeah, if you have anything to return, that's possible. No need to completely inline it. Okay. Keywords can also get parameters. We see 2 different kinds here. Yeah, we have the more parameter-like passing in the first part, where I just say, okay, I have a keyword that's called select 3 types, which I give 2 parameters, and I have a keyword, or I have a keyword that has the parameters directly inside. Yeah. In the first example, I could have 1, 2 arbitrary length parameters, while in the second one, it's really part of how the keyword is named. How do I implement it when I don't want to use Python right now? I can use these arguments tag and just give the argument a name and then execute the different keyword I want to break it down to, or I pass it directly in the name of the keyword. So it's easier to see there, but then I would also need to structure my keyword in this way. The whole keywords are normally not directly part of the test suite, as you can, or you should be able to reuse them in not only multiple tests, but also in multiple test suites. So Robot Framework has also a concept that's called resource file, where you just can put all keywords inside and can, as seen before, just import it in the test suite to not replicate it anymore. Okay, we're nearly at the bottom of the framework, but we have 2 things that we still need to consider, and that is, okay, I have keywords, I can break it down to keywords, and then I can also break it down to keywords, but when do I actually start the implementation? And that is, well, it depends on the kind of keyword, and we'll look at 2 of them now. Yeah, we'll look at this way, or this keyword, which looks very CSS-likey, and this keyword, which is a bit better to read and a bit more specific. The single answer for that is, well, you can simply use libraries that other people already wrote and are generic enough for your use case. Yeah? In this case, you just write down the library and the library name keyword. Install this library, obviously, before. For example, for my users click simulation, I've used the browser library provided by Robot Framework, which is also just available by PyPy. I need to install some browsers, so this is why there is this rf browser in it. But then I can simply use, for example, this select options by keyword, which has great documentation and says, okay, you can interact with any website element by providing a CSS or an ID or anything that you want to. So you can, you do not need to write anything yourself. If you want to have functionality that is not easily provided by any function because it's domain specific, because you need it specifically for your use case, you can also implement their own libraries. Yeah, and having own keywords is as simple as it gets, and we'll look into it. Yeah, in this case, I just have written a map analyzer library that extracts accidents and things like that, so I can count it. And this can be just a simple Python file that I lie beside that. I can then use it in my keywords, and the implementation itself looks super complex, but the main functionality lies here. Yeah, I have this add keyword decorator from Robot Framework, I write the name of the keyword inside, give it a name, give it the parameter that it expects, and then I implement it in a functionality that I think is matching the keyword definition properly. Yeah, so no need to have a complex hierarchy, to have a lot of rules, but just this decorator and the properly named keyword. You can, if you want to, also extend it a bit and actually use classes in a way. Yeah, so you can also, okay, classes or a whole library. I've changed the example here a bit that I have a whole class. The keyword implementation below is pretty much the same. The big advantage if I want to do that is I can actually give in parameters if I want to while I import my library. Yeah, so my map analyzer library pi now gets also a color I search for. Yeah, this a blue color because my points before were blue. But this way I can get more flexible, and if I want to or need more keywords, I need have more complex cases, I can build it up so it's a complete Python package with everything that belongs to it, can have utility functions, can have functions that are not directly part of the library concept, but by yeah, just having a normal structure. Okay, and this way you could implement all keywords by yourself. Okay, last but not least, what we are normally interested in tests is executing the tests. Yeah, and this, I had it on the slides before, is pretty simple. I just execute or call robot on the suite name or in a whole folder, and it will automatically search it. It will initialize everything that it sees. And you get, I hopefully one can see it, you get at first a single print in your command line interface, which says, okay, this case passes, this case fails. Great so far. But what I personally like is that it also provides a log HTML file that you can open in your browser, where you have a detailed information about each test, about each keyword, about each step that happens. And for example, here, a bit hard to read, yeah, I have a test with, or a keyword that ensures that the numbers are properly passing, which is now failing, and it also gives me the names. So when I need to debug anything in this regard, this is pretty simple. And while I've talked a lot and very fast, there's way more in Robot Framework. One could easily fill another half an hour. I'm just teasing a bit what you can actually do. The Robot Framework language also had things like if and while, and if you really do not want to write Python, you could also do that in their own syntax. You have listeners that execute code, modify results of tests, have own asserts, can modify the report format if you want to. You can have libraries not only statically, but created dynamically at runtime. You do not need directly run Python if you really do not want to, but also can have libraries in other languages. And especially the tooling and the documentation around these keywords is super powerful, pretty styled, and you find all information that you need to. So for me, I would definitely try or would suggest for you to use Robot Framework. It gives a common understanding of stakeholders and developers. It's at least the test cases are pretty easy to read because they express exactly what and how a user would actually do with a website. And the expression language is pretty flexible. Yeah, you can express everything that you want to. Unfortunately, it's not so easy to learn, especially for the non-technical people. You have a different tooling beside normally PyTest, and that's the thing. There's only Robot Framework and the libraries give you a level of abstraction of other features. This browser library, for example, has Playwright below, and some nice features from Playwright I just lost by having this layer of abstraction. Okay, let's summarize it shortly. We have common ground because between stakeholders and developers. We have executable test cases, not only the specification. we have test suites that uses different keywords that are implemented by libraries from us or by the open source community. And we can express it by implementing or extend it by implementing a library with a single file if it needs to get quick, or by a whole Python package if we have complex example. And that is also a good reason why to look at it. You can commercially use it as the license is allowing it, and you don't get in trouble with that. And with that, that's my part. I would be open for some questions if there are any. Thank you.
So thank you, Stefan. So do you have any question? So maybe then I'll have some short one. So as I understand, your framework is kind of communication between the people who develop and people who ask.
Yeah.
What do you think? What is the limitation of your approach?
What is the limitation? I think for most use cases, especially for developers, it's still easier to write PyTest and to break it down on PyTest and I would say keep it in their world, because like it's hard for the stakeholders to understand my unit tests that I would write in Python. It's also hard for me to express the tests in a way that it has a good level of abstraction and is really on the level that my project owner or stakeholders would understand. That's a limitation that you would still need to find a good middle way of actually bringing both sides together and actually working together to have proper test specifications and to properly also implement the keywords, as you do not get that for free either.
I see. And maybe one short question. Do you think after like a couple of years the LLM will be the advantages to your framework?
I have not tried it out, but when my product owner cannot properly understand and express, I'm not sure if LLMs can do.
I see. Okay. Thank the speaker one more time.